So in the previous video, we learned about what are trees, what are binary trees, and how do they work. So if I revise this real quick, so let's say this is a tree. So we have a parent node or a root node, which is connected to some more nodes, and those nodes are again connected to some more nodes. So in tree, we remember that there was one restriction that a cycle cannot be formed in a tree. So if like this cycle is formed in a tree, this was not allowed. But in the case of graph, there is no such restrictions. Cycles can be formed or may not be formed. So we can basically say that all trees are graphs, but all graphs are not tree. So a graph data structure is basically a collection of node that have data. So as we can see here, this graph, it is a collection of node, and each node has its own value or data, and each node of the graph is connected to some or the other node in the graph. So this is nothing but a graph, as simple as that. We have some terminologies in graph. The first terminology is adjacency. So we can say adjacency is nothing but the adjacent nodes to a given node. So suppose we consider this node 1, the adjacent nodes to node 1 will be 3 and 2. Similarly, adjacent node to 3 will be 5 and 4, and so on. So the next terminology is weighted graph. So in some graph, the edges have some weight. So for example, if we consider this edge between 1 and 3, and if we give some weight to this edge, let's say we give 4. So a weight is nothing but any quantity like distance or time. So when we give some weight to edge, it becomes a weighted graph. So these were some terminologies of graph. Let's move forward to graph representation. So here I have taken a graph, and this graph has 7 edges, and I have represented these edges in a list. So as you can see, the edge 0 comma 1, here is the edge 0 comma 1, then 0 comma 3, we have the 0 comma 3 edge, then 0 comma 4, this is 0 comma 4, then 1 comma 2, this is 1 comma 2, then 1 comma 5, we have 1 comma 5 here, then 2 comma 4, this is 2 comma 4, and at last 3 comma 4. So we have represented this graph in terms of edges, but this is not a very efficient way to represent. So we represent a graph usually by an adjacency list or adjacency matrix. So let's see how to create an adjacency list or an adjacency matrix. So now let's create an adjacency list and represent a graph using it. So I have taken here n equals to 6, which is nothing but number of nodes, and I have taken these edges which represent the graph, as we have seen earlier. I have taken these edges, and now what I will do is I will create an empty list called adjacency list and append an empty list to it. So if I do this, so now our adjacency list would be looking like this. And further, I will again run a loop for edge in edges. At last, I will try run this code again for perfect understanding. So don't need to worry about that. I will first finish this code quickly. So now I will create a variable x and assign the first element of the edge to it, and then create a variable y and assign the second element of edge. So now what I would do is at the x index of the adjacency list, I will append y, and at the y index of the adjacency list, I will append x. So now our adjacency list is created. So now quickly dry run this for a better understanding. So now we have a graph with 6 nodes, and these are the edges of the graph. So now what we did was we created an empty list called adjacency list, and we appended an empty list into that adjacency list. So now our adjacency list look like this. So now you may say that how is this list going to represent a graph? So let me tell you, if we consider this list at index 0, so let's say this list represent node 0, and in that list we will be appending the elements which are the adjacent nodes of node 0. So we can say that 1, 3, and 4 are the adjacent nodes to node 0. So 1, 3, and 4 will get appended at index 0 of at list of index 0. And similarly, this will be our node 1, which is at index 1. So adjacent nodes to node 1 are 5, 2, and 0. So here 0, 2, and 5 will be appended. So now let's see at index 2, which will be our node 2. So node 2 have adjacent nodes 1 and 4. So 1 and 4 will be appended at index 2. Similarly, if we see for index 3, this will be our index 3. Here you can see 0 and 4 are adjacent to node 3. So at node 4, we can see 0, 2, and 3. These are the adjacent nodes to node 4. And at last, node 5, there is only one adjacent node, that is 1. So this is what our adjacency matrix will look like. Sorry, adjacency list will look like. So now let's see how we will create this list. So what I did is I ran a for loop for edge in edges. So for the first iteration, our edge will become 0 comma 1. As you can see here, the first element in the list edges is 0 comma 1. And I assigned a variable x to the first element of the edge and variable y to second element of the edge. So our x will be 0 in this case for the first iteration, and y will be equal to 1. So this is where the main part is. So what I did is at the x index of the adjacency list, that is here at the 0th index of the adjacency list, I appended y, that is I appended 1. So our adjacency list will now look like at the 0th index I will append 1. Now similarly, at the y index of the adjacency list, I will append x. So at the first index of the adjacency list, I will append 0. So at this is the first index. This is the first index. In that, I will append what's happening with this. Yes, so I will append 0. So why did I did this? Because as you can see in this graph, we know that the adjacent node to node 0 is 1, but at the same time the adjacent node to node 1 is also 0. So that's why we had to do this. Now coming to the next iteration, we have 0 comma 3. So now our edge will become 0 comma 3. So again the value of x will be 0, and this time the value of y will be 3. So now what will happen is at the 0th index of the adjacency list, we will append 3. So here we will append 3, and at the third index we will append 0. So 0, 1, 2, 3. Here we will append 0. So now again the next iteration will take place, and this time the edge will be 0 comma 4. So now the edge will be 0 comma 4. The value of x will be 0 and y will be 4 this time. So now y will become 4, and again at the 0th index I will append 4. I will append here 4, and at the 4th index I will append 0. So 0, 1, I will name the indices. This is 2, this is 3, this is 4. Sorry, I messed up a bit. This is index 1, this is 2, this is 3, this is 4, and this is at last index 5. So at the 4th index I will append 0. Here I will append 0. So now our edge, again the iteration will take place, and this time our edge will be 1 comma 2. So now our edge will become 1 comma 2. So this time the value of x will be changed to 1 and the value of y will be 2. So at the first index of the adjacency list, I will append 2. Here I will append 2, and at the second index I will append 1. Let me erase these indices because these are causing a bit trouble. Okay, so now next iteration again will take place, and this time the edge will be 1 comma 5. So edge, now our edge will be 1 comma 5. So value of x will remain 1 and y will change to 5. So again at the first index I will append 5. Will append 5, and at the fifth index I will append 1. So this is our fifth index, I will append 1. So again the iteration will take place and the edge will become 2 comma 4. So again we will take edge as 2 comma 4, and the value of x now will be 2 and the value of y will be 4. So again at the second index I will append 4. At the second index I will append 4, and at the fourth index I will append 2. So here I will append 2. So now again next iteration will take place, and this time it will be called for 3 comma 4. So now our edge becomes 3 comma 4. So x becomes 3 and y remains 4. So at the third index I will append 4. At the 0 1 2 3, this here third index I will append 4, and fourth index I will append 3. So now you can see this list which we created earlier, and this is same. So this is how we create an adjacency list. So now let's print this adjacency list on the terminal. So for that I will run a loop in range n, and I will print I, which will be our node, and it will be pointing to the adjacent nodes of I. So if I run this, the adjacency list will be printed. So as you can see, so node 0, it has adjacent nodes as 1 3 and 4. As you can see that node 0 adjacent nodes are 1 3 and 4. At node 1 adjacent nodes are 0 to 5, 0 to 5. So this is how we create an adjacency list and represent a graph using adjacency list. So now moving forward, we will learn about adjacency matrix. Before moving to adjacency matrix, I would like to tell you that sometimes we are not given an adjacency list. We are given a dictionary which represents a graph. So this is a dictionary which is representing a graph. The key is the node, and its value is nothing but the nodes adjacent to that key. So here we can see that our key is 0. So here our node 0 and its values are 1 3 and 4. So these values are nothing but the adjacent nodes to that key. So here we can see we had at index 0 adjacent nodes at 1 3 and 4. Similarly here at key 0 we have adjacent nodes as 1 3 and 4. So this is how we can also represent a graph using dictionary. So now moving forward, we have adjacency matrix. So adjacency matrix is nothing but it is basically used to check whether there is edge between any two nodes of a graph, and the size of adjacency matrix is always n cross n, where n is nothing but number of nodes in a graph. So in adjacency list, we saw that this node 0 is connected to 1 3 and 4. So similarly, if we want to represent this in a matrix, we say that we know that there is an edge between 0 and 1. So at position 0 comma 1 we will say it has edge. So we will fill the box 0 comma 1 with value 1. So also there is edge between 0 comma 3. So we will also insert 1 here. then we have 0 comma 4, and then we have 1 comma 0. This is 1 comma 0, then 1 comma 2, this is 1 comma 2, 1 comma 5, similarly 2 comma 1, 2 comma 1, 2 comma 4, then we have 3 comma 0, then we have 3 comma 4, then we have 4 comma 0, this is 4 comma 0, then 4 comma 2, 4 3, and at last 5 1. So all the boxes which are filled with 1 represents that there is an edge between the numbers. So this box 0 comma 1 represents has 1 in it, so it represents that there is an edge between 0 comma 1. Similarly, as there is an edge between 0 comma 1 and the graph, provided that the graph is not a directed graph, so there will also be edge between 1 comma 0. So here also we have inserted 1. Similarly, all the boxes representing 1 tells us that there is an edge between those numbers, and the remaining boxes we can fill with -1. So this represents that there is no connection between these nodes. So this is what an adjacency matrix is. Now let's quickly go to VS Code and create an adjacency matrix there. So for adjacency matrix, what I will do is I will take the same graph which we did in the case of adjacency list. So I will create an empty list called adjacency matrix and run a loop in range n. And what I will do is I will append a row with n elements, and the value of every element in that row will be -1. So after each iteration and the loop is completed, then we will have an adjacency matrix of 5 by 5 with each element as -1. So now what I will do is I will run a for loop for edge in edges, and again assign variable x to the first element of edge, like similarly what we did in adjacency list, and assign a variable y to second element of edge. Now what I will do is to the xy index of the matrix, I will rewrite it as 1, as there is link between x and y, and so as there is link between x and y, there will also be a link between y and x, provided the graph is not directed. So this is pretty much similar what we did in adjacency matrix. If you want, you can try run for better understanding. And now I will print the adjacency matrix. So if I run this, this is the adjacency matrix which we wanted. So for comparison, let's see if it works. So this is what we discussed before, the adjacency matrix. Let me delete this. So yes. So this is what we discussed before, and this is what we got as output after running the code. So these two are similar. So this is how we create an adjacency matrix in graph and represent a graph using it. So in the next video, we will be discussing about what are priority queues or heap data structure in Python, which is very important data structure, which we will also be using for implementing some searching algorithms like greedy best first search and many more. So that's it for today. See you in the next video.